Good morning, students. In this video lecture, we are going to discuss the reversibility of light, and that reversibility of light we first demonstrate an experiment to you, and then we will discuss its theoretical part of. Okay, so let's move to the demonstration. So in this demonstration, here we have one laser pointer, which is a green laser, and a glass slab which can provide us the glass medium for the refraction. Okay, so around this glass slab you can see that there is a medium of air, but inside the glass there is a denser medium. Okay, there is a glass medium. So when we light pass through this glass slab, it should deviate from its path as we had studied in the refraction law, and when it emerges out again in the air, then it also follow its normal path. Okay, so this is our point of attraction today. Here we are going to demonstrate this experiment. Okay, so please hold this laser like this. Here, hold it. Now, student, as you see, if you see over here, please press it firmly. Now you can see that there is a laser light coming through the laser and it enters in the glass slab and again emerging out. So you can see that there is a sharp red line. There is a sharp red line showing in the glass slab, which is representing the path of refracted ray. As we had studied earlier, that when light goes from one medium to other medium, it deviates from its path and as well as it changes its wavelength. So here we entered the green laser and somehow it appears little bit saffron. It appears in saffron in color in the diagram in this demonstration, and again when it emerging out, here it is going in the pathway of this direction. So you can easily see that there is a deviation. First deviation is occur here, and then second deviation is from air to glass medium, and again the another deviation glass to air medium. Okay, so now we will discuss the principle of reversibility related to this particular experiment. Okay students, so जैसा कि अभी आपने demonstration में देखा, so that same demonstration now we are going to discuss that theoretical part over here. So here we have taken a glass slab, okay, which have the different medium. Of course, there is a kanch, there is a glass, so there will be a different refractive index for this medium, and it is, here is air and here is also air. So obviously we have two media interface, one air to glass and then glass to air. So our ray, this is our laser pointer, suppose for example this is our laser. Okay, so our laser light will suffer refraction two times, first from air to glass medium and then glass to air medium, and we have to understand that what the reversibility of light in the contrast of this experiment. Now let me show you, as from Snell's law we know that the angle of sine for incident angle and for refractive angle, that is the ratio of sine I1 and sine R1 is must be equal to the refractive index of glass medium with respect to air for first case, for first refraction. Okay, because light is coming from air medium to glass medium. So if I talk about point A, so at point A the light will suffer the refraction, angle is, incident angle is I1, refractive angle is R1. So according to the Snell's law, the sine I1 upon sine R1 must be equal to refractive index of mu, refractive index of glass with respect to air, that is mu G over mu A. Now for second refraction, if we talk about the second refraction, So if you taken the point here is B, so you clearly observe that light is now coming from glass to air medium. It means what we take in the refractive angle over here, sorry, incident angle is I2. So that is sin I2. And refractive angle we take in the R2, so sin R2. And this ratio must be equal to the refractive index of air with respect to glass. Refractive index of air with respect to glass, that is mu A over mu G. Now, suppose this is our equation 1 and this is our equation 2. This is our equation 2. So just now look at that. Here is mu G over mu A, which is sin I1 upon sin R1, and here is mu A over mu G, which is sin I2 over R2. And now if you little bit observe here, so the normal here and normal here are parallel to each other, which means interior angles, or we can say Z shape angle, must be equal to each other, which means angle R1 must be equal to angle I2. So instead of using I2, we can replace R1 here, sin R1. Now, as we know that this normal is also parallel to this one, and this light ray is parallel to this one, which means angle R2 is actually equal to I1. Angle R2 is actually equals to I1, which means we can replace R2 with I1. Rest of the same. So now it is quite clear that when light comes from air to glass and then the refractive index is mu G with respect to A, then when light suffer the second refraction, when it comes from air to in glass to air, then the refractive index is air with respect to glass, which means they are quite reciprocal to each other. If you observe this equation 1 and this equation 3, then you can easily conclude this relation that the refractive index of air with respect to glass is actually reciprocal of refractive index of glass with respect to air. And this principle, this phenomena, this event is nothing but the call reversibility of light. So till here we understand the process of reversibility which is happening in the refraction. And one more thing we observe over here, that when light suffers the refraction, it deviates from its path when it also changes its wavelength. But remember, it changes its wavelength, not the frequency nor the energy. Okay, so that is the key point for this video. I hope you like this experiment and the explanation. If you like this, then please like, share and subscribe. Thank you, learners.